A vibrant koi pond is a breathtaking spectacle, yet the health of its prized inhabitants and the clarity of its water rely entirely on one critical component, a good koi pond filter. Without a robust filtration system, your beautiful feature quickly becomes a cloudy, toxic environment where fish cannot thrive. The search for the best filter is a quest for balance, seeking an efficient combination of mechanical filtration to trap debris and biological filtration to neutralize harmful ammonia and nitrites. Understanding the various options, from multi-stage box systems to advanced drum and gravity-fed filters, is the first step towards securing a healthy, crystal-clear aquatic haven for your beloved koi. Understanding the three pillars of koi pond filtration: mechanical, biological, and UV. A truly robust filtration system is built upon the synergy of three essential components: mechanical, biological, and ultraviolet UV filtration. This trio works in concert to maintain the pristine water quality necessary for a healthy koi environment. Mechanical filtration acts as the crucial first line of defense, much like a vacuum cleaner for the pond water. Its sole purpose is to physically separate and remove large solid waste, such as fish waste, uneaten food, and wind-blown debris before it can break down and pollute the water. Filter media, like mats or screens, are used to trap this detritus, and regular cleaning of this stage is vital to prevent the rapid accumulation of toxic compounds. The next, and arguably most vital, stage is biological filtration. This process tackles the invisible, but deadly, dissolved waste in the water. Koi constantly produce ammonia, a substance highly toxic to them, which must be neutralized. Biological filters provide a massive surface area for beneficial bacteria, specifically Nitrosomonas and Nitrobacter, to colonize. These bacteria perform the life-saving nitrification cycle, converting the harmful ammonia into nitrites and then further into the much less toxic nitrates. This ensures a stable, non-toxic environment, directly correlating with the health and longevity of your prized koi. Finally, UV filtration completes the triad by providing crystal-clear water and pathogen control. UV sterilizers or clarifiers pass the pond water over a special ultraviolet light bulb, which targets and neutralizes suspended single-celled algae, which are the primary cause of green, cloudy pond water. While not a primary filter, UV components are also essential for controlling the spread of harmful microorganisms and pathogens, providing a critical safeguard against fish disease. The search for a good koi pond filter is therefore a quest to find a system where all three pillars, mechanical efficiency, biological power, and UV clarity, are balanced to meet the specific demands of your pond's volume and fish load. Gravity-fed versus pump-fed systems. Which setup is right for your pond? When designing your koi pond's filtration, one of the most fundamental choices is between a gravity-fed and a pump-fed system. The decision dictates the system's layout, ease of maintenance, and long-term running cost. A pump-fed system is the most common and simplest setup for smaller, less intensive ponds. In this arrangement, a submersible pump is placed directly in the pond, pushing water up through a hose to an external filter unit, which is situated above the pond's waterline. Gravity then returns the clean water to the pond via a waterfall or return line. Its major advantages are a lower initial cost and incredibly easy installation, as no permanent pipework below the waterline is required. However, the pump's impeller can chop up solid waste, or fines, into smaller pieces, making mechanical filtration less efficient. Furthermore, constantly lifting water to a higher filter unit increases energy consumption, leading to higher long-term running costs. Conversely, a gravity-fed system is considered the gold standard for dedicated koi ponds. Here, the filter unit is buried adjacent to the pond, and the pond's bottom drain is connected directly to the filter intake, allowing water to flow by natural gravity. The pump is then positioned after the filter, pushing the already clean water back into the pond. This configuration is far more efficient, as the pump only needs to overcome friction and head loss rather than lift water from pond level to filter level, translating to lower electricity bills. Critically, because the pump is post-filter, solid waste is not minced, allowing the mechanical stage to capture larger debris for superior clarity and reduced filter cleaning. While initial installation is more complex and costly, requiring a bottom drain and precise filter placement, the enhanced performance, reduced energy use, and lower long-term maintenance make it the definitive choice for serious koi keepers with larger ponds. The mechanical stage. Pre-filtering debris with sieves and rotating drum filters, RDF. The primary goal of the mechanical stage in a high-end gravity-fed koi pond system is to remove as much solid waste as possible before it can break down into dissolved pollutants or clog the subsequent biological media. Because the pump is located post-filter, the coarse debris, including fish waste, uneaten food, and leaves, remains intact, making its capture far more efficient than in pump-fed setups. The most effective technologies for this critical pre-filtering role are the venerable sieve and the modern automated rotating drum filter. Sieves represent a low-tech, reliable solution, acting as the very first point of filtration. Installed in line with the pond's waterline in a gravity-fed configuration, the pond water flows directly over a fine bow screen, typically sized to trap particles down to 300 microns or less. Coarse waste particles are separated and slide into a collection basin, while the filtered water passes through to the next stage. A key benefit is their simple operation, requiring only manual flushing of the collected waste, providing highly effective mechanical separation with no moving parts. For the ultimate in hands-off performance, the rotating drum filter, RDF, has become the definitive choice for serious koi keepers. The RDF automates the pre-filtration process, utilizing a cylindrical drum covered in an extremely fine mesh screen, often capable of trapping solids as small as 74 to 200 microns. As water flows through the screen, solid waste gradually blocks the mesh, which lowers the water level inside the filter chamber. Sensors detect this drop, triggering a cleaning cycle. The drum slowly rotates, and high-pressure jets wash the trapped debris into a waste tray, which is then flushed away. This automated, continuous cleaning maintains flow and eliminates the need for daily manual maintenance, providing consistent, high-precision filtration and crystal-clear water with minimal effort. The biological backbone, key filter media for the nitrogen cycle. While high-precision mechanical filters, like the rotating drum filter, RDF, remove solid waste, they only address the first stage of pond cleanliness. The true health of a koi pond rests on the biological filter, which houses the beneficial bacteria responsible for the vital nitrogen cycle. This process is the core defense against dissolved toxic waste, converting lethal fish waste, ammonia and nitrite, into the far less harmful nitrate. The key to effective biological filtration lies in the filter media, which is specifically engineered to provide an immense protected surface area for these bacteria to colonize. Biological media is broadly categorized into static bed and moving bed systems. Static media, such as high-porosity ceramic rings, sintered glass, or bioballs, is typically housed in a submerged chamber where water flows through it. Ceramic media, for example, is favored by serious koi keepers for its chemically inert nature and extreme porosity, which drastically increases the area available for biofilm growth within a small volume. Filter mats are another form of static media, offering a structured surface where the colonies can thrive. For maximum efficiency and consistency, many modern systems utilize moving bed biofilm reactor media, most famously seen in the form of Caldness K1 media. These small, buoyant, wheel-shaped plastic pieces are designed to tumble freely in a dedicated, aerated filter chamber. This constant, gentle movement causes the oldest, outermost biofilm, sludge, to be continuously sloughed off, which is a self-cleaning mechanism that prevents media clogging and ensures a continuously active, young biofilm layer remains. This mechanism maintains a consistently high conversion rate of ammonia and nitrite, which is crucial for heavily stocked koi ponds and is considered the ultimate in hands-off biological performance to complement the mechanical separation of an RDF. Sizing your filter. calculating for pond volume and koi population density. Effective filtration begins with an accurate assessment of the water volume and, more importantly, the biomass or bioload of your pond. While a simple rectangular pond volume can be calculated using the formula length, Ft, times width, Ft, times average depth, Ft, times 7.48 to determine gallons, irregularly shaped ponds may require a more hands-on approach, such as using a water meter during filling or using the salt method for a highly accurate final measurement. Once the volume is known, the target flow rate for the entire filtration system should be established. For koi ponds, this is typically a turnover rate that processes the entire pond volume at least once per hour to maintain water quality. However, the size of the biological filter media cannot be determined by volume alone. It must be sized according to the bioload. This bioload is the amount of ammonia-producing waste generated, which is directly tied to the weight of the fish and the amount of food they are consuming. A general guideline for healthy koi stocking density is to allow approximately 250 gallons of water per adult koi to ensure ample space for growth and waste dilution. For high-performance biological filters, such as those utilizing moving bed biofilm reactor (MBBR) media like Coldness K1, filter sizing is calculated based on the media's protected surface area and its nitrification rate, (rtan), not just pond volume. A practical rule of thumb, which can vary with feed rate and specific media type, suggests that about 50 liters of media, like a K1 variant, can support roughly 16 kilograms of fish when fed at a typical maintenance rate, e.g. 1.5% of body weight per day. Furthermore, 100 liters of Coldness K1 media is rated to handle approximately 500 grams of food per day. Therefore, for a heavily stocked koi pond, it is crucial to oversize the biological filter to manage potential fluctuations in ammonia and nitrite, ensuring the system can easily support the maximum projected bioload rather than the current small fish population. Essential role of UV clarifiers in controlling green water and algae. While the mechanical and biological components of a good koi pond filter system are paramount for managing solid waste and harmful nitrogenous compounds, they do not inherently address the issue of single-celled planktonic algae, the direct cause of green water. This is where the ultraviolet UV clarifier assumes its essential role as a dedicated component for water clarity. Green water, while not toxic, obstructs the view of the prized koi and diminishes the pond's aesthetic appeal, making a UV clarifier a standard inclusion in high-performance setups. The clarifier works by leveraging UVC light, a germicidal wavelength of ultraviolet radiation inside a sealed chamber. As pond water is pumped through this unit, the single-celled algae are exposed to the intense UVC light. This radiation damages the algae's DNA, preventing cell division and replication. More importantly, the damaged, non-viable cells begin to flocculate or clump together. This process transforms the microscopic organisms, which would otherwise pass straight through a filter, into larger particles that can be effectively captured and removed by the mechanical filtration stage, such as filter pads or a bead filter. For the UV clarifier to function as an effective filter complement, correct sizing is critical. The wattage of the UV bulb must be appropriately matched to the pond's volume and, more importantly, the pump's flow rate. If the water passes through the UV unit too quickly, the contact time with the UVC light will be insufficient to inflict lethal damage on the algae cells, rendering the unit ineffective. Conversely, too slow a flow rate is inefficient for overall pond turnover. Therefore, a successful koi pond system integrates the UV clarifier's optimal flow rate, often specified by the manufacturer, with the main pump's capacity to ensure consistent, lethal exposure for algae cells, guaranteeing crystal clear water without compromising the crucial nitrification process happening in the biological filter. Advanced filtration technologies, a look at bead filters and high-capacity systems. For koi keepers managing a high-density pond or simply seeking minimal maintenance, advanced mechanical and biological filtration is paramount. Bead filters represent a highly popular and effective solution, uniquely combining both mechanical and biological filtration into a single, compact, pressurized vessel. Inside the unit, thousands of small plastic beads are tightly packed to serve a dual purpose. Mechanically, the beads trap fine solid waste as water is pushed through, ensuring the clarity that follows a well-functioning UV clarifier. Biologically, their massive collective surface area provides an ideal, highly concentrated habitat for beneficial nitrifying bacteria, supporting a thriving ecosystem and healthier fish. While highly versatile and often flexible in installation due to their pressurized nature, bead filters have limits to their mechanical capacity when dealing with extremely heavy solid waste loads, which can lead to frequent backwashing or clogging if not paired with efficient pre-filtration. For the largest ponds, or those with the heaviest bioloads, where space and capacity are prioritized over a single unit solution, other high-capacity systems come into play. A primary example is the moving bed bioreactor, or moving bed filter. Unlike a bead filter, the MBBR is a dedicated biological filter utilizing specialized media that is constantly tumbled in the water, maximizing oxygen contact and biological efficiency 24/7. These high-capacity biological filters are often paired with a dedicated, high-efficiency mechanical pre-filter, such as a sieve filter or a modern drum filter, to remove large solids before they break down. This modular, two-stage approach allows each component to be optimized for its specific task. Unparalleled mechanical removal of sludge, followed by maximal biological conversion of ammonia, creating a powerhouse system capable of sustaining the most demanding koi environments. Choosing a user-friendly filter, focusing on maintenance and cleaning features. For the dedicated koi keeper, a filter's true value is often measured not by its maximum theoretical capacity, but by the ease and speed with which it can be maintained. The most powerful filtration system will eventually fail if its cleaning process is so laborious that it is neglected. Consequently, a user-friendly design that minimizes hands-on time is the hallmark of a good koi pond filter. The primary feature differentiating user-friendly filters from their high-maintenance counterparts is the inclusion of hands-free or automated cleaning mechanisms. Pressure and bead filters, for example, often incorporate a simple backwash function. This system allows the pond keeper to clean the mechanical media, the sponges or beads that trap debris, with a mere flip of a valve or switch, without having to open the unit, remove the media, and manually hose it down. This automated rinse cycle reverses the water flow, flushing out trapped sludge and debris through a dedicated waste port, making routine cleaning a matter of minutes instead of an hour. Beyond simple backwashing, advanced systems have evolved to offer even greater convenience. Self-cleaning pressure filters with built-in UV clarifiers represent a significant leap, designed to be efficient, self-cleaning units with minimal manual effort. For those using modular, two-stage systems, the mechanical pre-filter is the most frequent point of required maintenance. Here, modern drum filters, RDFs, provide the ultimate in automation by continuously monitoring the flow and automatically initiating a clean cycle, which sprays waste into a separate chamber for disposal, effectively eliminating daily manual sludge removal. In contrast, traditional gravity-fed or black box filters typically require the frequent physical removal and hosing down of foam or filter mats, a messy and time-consuming chore that risks interrupting the beneficial bacteria colonization of the biological media. Therefore, when selecting a filter, prioritizing mechanisms like self-cleaning backwash, easy-access drain points for heavy sludge, or fully automated cleaning cycles is key to ensuring a sustainable, long-term maintenance routine that keeps the pond pristine with minimal effort. Integration: combining filtration, aeration, and bottom drains for optimal health. While an automated mechanical filter, such as a drum filter, RDF, addresses the bulk of solid waste and the maintenance burden, achieving truly optimal pond health requires integrating this technology with a strategically designed circulation and oxygenation system. The ultimate strategy for a low-maintenance, high-health koi pond is a three-part synergy: efficient mechanical filtration, powerful aeration, and strategically placed bottom drains. Bottom drains are the foundational element of this system, acting as a continuous vacuum for the pond floor. By sitting at the deepest point, they utilize gravity to channel heavy detritus, fish waste, and settled sludge directly into the mechanical prefilter, like the RDF, before it can decompose and foul the water. This constant, efficient removal prevents the accumulation of noxious gases and pathogens, which are detrimental to koi health. The power of this setup is amplified exponentially by incorporating aerated bottom drains. These units feature an air diffuser that releases a curtain of fine bubbles from the pond floor. This serves a critical dual purpose. First, the rising column of bubbles creates a powerful upward current that scrubs the pond bottom, driving waste toward the drain inlet. Second, and equally vital, this process ensures the maximum saturation of the deepest water with dissolved oxygen, a necessity for both the koi and the health of the beneficial bacteria colonizing the biological filter media. This combination forms a perpetual cleaning cycle. The bottom drains and aeration work in concert to concentrate and deliver waste to the automated filter, e.g. the RDF. The filter handles the mechanical separation with minimal human intervention, and the high dissolved oxygen levels support robust fish immune systems and a highly effective biological stage. The result is a pristine, oxygen-rich environment with minimal effort, ensuring sustainable, long-term health for the koi. Top-rated koi pond filter systems and brands on the market. The pursuit of pristine water quality for high-grade koi has driven the market toward highly automated and efficient filter systems, which seamlessly integrate with the bottom drains and aeration described previously. The consensus among serious hobbyists and professional pond builders is that rotary drum filters, RDFs, represent the gold standard for mechanical filtration. Brands like Oasis ProfiClear Premium XL and ProfiDrum lead this segment, offering cutting-edge technology designed for the professional hobbyist. An RDF works by passing pond water through an incredibly fine sieve, typically 50 to 100 microns, housed within a rotating drum. As sludge and debris clog the screen, water flow is impeded, triggering an automated backwash cycle that cleans the screen and flushes the waste away with minimal water loss. This self-cleaning process ensures continuous, high-performance mechanical separation, removing even the smallest particulate matter before it breaks down and pollutes the water. This efficiency is crucial, as the rising column of waste delivered by a bottom aerated pond needs rapid removal to maintain clarity and low nutrient levels. Following the RDF's ultrafine mechanical stage, a robust biological filter is essential. Top-rated systems often employ advanced technologies like moving bed bioreactors, MBBR. The Evolution Aqua Nexus Plus filter, for instance, is highly regarded for its K1 micromedia, which provides a massive surface area for beneficial bacteria to colonize and efficiently convert harmful ammonia and nitrite into harmless nitrate. This two-stage approach, automated RDF for mechanical filtration and a high-capacity MBBR for biological, is the dominant trend in top-tier koi pond management. For smaller ponds or systems with less intensive feeding, all-in-one or pressurized filters from brands like Oase, FiltoClear, or Pond Expert still provide excellent results, often integrating a UV clarifier to combat greenwater algae. However, for large, heavily stocked koi ponds, the combination of an RDF and a dedicated biological reactor system offers the best assurance of sustainable water health and minimal maintenance. The consensus for top-tier koi pond management favors a two-stage filtration system, setting the gold standard for water health. Mechanical filtration is best achieved by a rotary drum filter, RDF, such as those from Oase or ProfiDrum. These automated systems use a fine sieve, 50 to 100 microns, to rapidly remove debris via a self-cleaning backwash, preventing pollution. Following this, a dedicated biological filter is crucial. Moving bed bioreactors, MBBRs, exemplified by the Evolution Aqua Nexus with its K1 micromedia, efficiently convert harmful compounds like ammonia and nitrite. While all-in-one filters suffice for smaller ponds, the RDF-MBBR combination is the dominant, most efficient trend for large, heavily stocked systems, guaranteeing superior water quality and minimal maintenance.